right, so with this question, we're looking at where is it continuous, where is it not continuous. The first thing that we notice, again, with continuity is that we know that fractions or rational functions, fractions will be continuous provided that the denominator is not equal to 0. So to answer this question, we're going to say, okay, where is the denominator equal to 0? So we need to solve e to the x minus 2 equal to 0. Now again, this is where all of the pre-calculus college algebra skills really come into play, because here we have our little cute variable in the exponent. So we have an exponential equation here that we need to solve. So because we have an exponential equation, the first thing that we're going to do is we're going to try to get the exponential term as much by itself as possible. So we isolate the base plus the exponent. All right, so if you look here, the base is e, the exponent is x. That is not isolated because of the minus 2. So hopefully, intuitively, you would agree that we should add 2 to both sides. And that will give us e to the x is equal to 2. Now, at this point, we need to come up with some way to get the x variable out of the exponent. And the way that we do that is we can either get a common base, and if you look at e and 2, there's no way a common base is going to happen there, or we can take the natural log of both sides. Now, you might ask, why do we need to take the natural log of both sides? Well, by taking the natural log of the left-hand side and taking the natural log of the right-hand side, there's two ways of doing this. One way is you could say that the natural log of e, they're inverses of each other, so they are going to cancel each other out. Or you could bring down the exponent, and we can bring down that exponent by our log properties that we talked about in pre-calc. So if I bring down this exponent, I will have x natural log e equals natural log 2. And when you compute natural log e, you get that that is equal to 1. So you have x is equal to the natural log of 2. All right, so remember, this is the number that we do not want to have. So all of this intermediate stuff was about solving the exponential equation. We started with it's continuous provided the denominator is not equal to 0. So we do not want this, we do not want this, we do not want this, do not want this. So that means that our conclusion that we're going to present here is that this function is continuous provided that x is not equal to the natural log of 2. Now, to answer the question of what type of discontinuity happens at the natural log of 2, remember, because we have a fraction, we want to ask ourselves, does that fraction denominator ever cancel out? And when you look up here, this denominator can't cancel. It's going to be there forever and a day because there's nothing up at the top that it's going to cancel out with the e to the x minus 2. And so because it cannot cancel, that means we have a non-removable, I'm going to abbreviate that, non-removable discontinuity at x is equal to the natural log of 2. Now, do also keep in mind that our particular textbook does not refer to it as non-removable. They refer to it as a infinite discontinuity. So you can also say it is an infinite discontinuity at the natural log of 2. And that's because, again, we know from our pre-calc days that when something doesn't cancel in the denominator, it's giving us a vertical asymptote.